Direct form to realization. Direct form to So in direct form 1 we have seen the structure for IIR filter. It requires m plus n memory units m plus n plus 1 multipliers, m plus n adders. Here in this direct form 2 we reduce the memory locations, number of memory locations. Hence it is called as canonic form. Canonic canonic form realization structure. See here we have seen the equation in the direct form 1 structure, that is y of n is equal to minus summation ak y of n minus k. Here k is 0 to k 1 to n, k 1 to n plus summation k 0 to m bk x of n minus k. So if you apply here Z transform on both sides, then it becomes y of z is equal to minus ak summation z power minus k y of z, summation k1 to n ak z transform of y of n minus k is z power minus k y of z plus summation k0 to m bk z power minus k x of z. So here y of z is nothing but, so common here, and then take this term here this side, then take the y of z as common. Now 1 plus summation k1 to n ak z power minus k, that is equal to summation k0 to m bk z power minus k into x of z. X of z is independent to the summation k value, y of z also. Now take the ratio y of z by x of z, that is summation k0 to m bk z power minus k divided by 1 plus summation k1 to n ak z power minus k. It is said to be h of z, transfer function of the particular IIR filter, h of z. So that's why here from this, so observe, you can get the zeros. From this we can get the poles, right? So okay, now consider this equation, that is equal to, that means h of z is equal to y of z by x of z. Now take one dummy variable, that is w of z. Hence we can write like this: y of z by w of z, w of z by x of z. W of z gets cancelled, then you can get y of z by x of z. So hence here y of z by w of z into w of z by x of z is equal to summation k0 to m bk z power minus k by 1 plus summation k1 to n ak z power minus k. So now let here consider like this: y of z by w of z is nothing but numerator polynomial, that is nothing but k summation k0 to m bk z power minus k. W of z by x of z is nothing but 1 by 1 plus summation k1 to n ak z power minus k. So from this write y of z is equal to w of z into summation bk z power minus k. Now expand w of z into b0 plus b1 z inverse plus and so on bm z power minus m. That means b0 w of z plus b1 z power minus 1 w of z plus and so on bm z power minus m w of z. This is the equation for y of z. Consider this one as equation A. Now take the another equation. From this, w of z is equal to here x of z by this one, then multiply here this one 1 plus summation k1 to n ak z power minus k is equal to x of z. So now from this w of z into into 1 plus summation k1 to n ak z power minus k is equal to x of z. So here w of z plus a1 z power minus 1 w of z plus a2 z power minus 2 w of z and so on an z z power minus n w of z is equal to x of z, and hence you can get w of z is equal to x of z minus a1 z inverse w of z minus a2 z power minus 2 w of z minus an z power minus n w of z. So consider this one as B equation. So right, from these two equations we can develop the direct form to realization structure, like here. So again I am writing here equations A and equation B. Equation A and equation B. What is the equation A? Y of z is nothing but b naught w of z plus b1 z power minus 1 w of z plus and so on bm z power minus m w of z. Equation B is w of z is equal to x of z minus a1 z power minus 1 w of z minus a2 z power minus 2 w of z and so on minus an z power minus n w of z. So here first we develop the w of z or w of n by using this equation. So here input is x of n. So here use the adder. So then here you can get the w of z or w of n. So now use the delay here z power minus 1, then here z power minus 1 w of z, multiply that one with the multiplier unit, that is minus 1 a1, then the resultant one is minus a1 z inverse w of z, which is added to the x of z. So right, so in this way here we finished these two terms. In this way up to an z power minus n w of z. So use the delays like z power minus 1 and so on, like this up to z power, up to get the z power minus n. So use the n delay units here and then use the multipliers like a minus a2 and so on minus an, then add all these values by using adders. Okay, so now in this way, so you can realize the equation w of z equation. Now from this w of z, so to realize this equation A, so here we have the w of z. Now see here, take b naught multiplier, then already we have here z inverse w of z. So use this one here and then multiply this one with the b1 and then add here all these terms. So here multiplier b2. then here you can get the y of z or y of n. See here, y of z is nothing but b naught w of z, b naught w of z plus here b1 z inverse w of z plus b2 z power minus 2 w of z plus z power minus of m minus 1 w of z into bm minus 1 plus z power minus m w of z. Here if m is equal to n, so we just here if m is equal to n, so we here draw like this. Okay, so equal number of delay units are necessary to draw this one, right? But here if m is not equal to n, one side, either any side, one side, so use the more delay units and then complete this multipliers and summers. Okay, here assumption is m is equal to n. Okay, that's why here, so the delay units, so here n or m, either n or m are sufficient to complete this structure. See here, this is the diagram, complete diagram. So in this way we can reduce the number of memory units when compared with the direct form 1. Okay, this structure requires m plus n plus 1 multipliers, of course same with the direct form 1, m plus n additions, this one also same with the direct form 1 structure. But here observe the delay units. Delay units are reduced here. Here maximum m comma n delay units are required, right? So that means if m is equal to n, m number of delay units are necessary. But in the direct form 1, it requires m plus n plus 1 memory units. Okay, so here this is the advantage here, and such that this is also called as canonic form. Thank you.